Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. In today's video we are going to discuss about difference between short column and long column. The column is the most important component of RCC structure. Various types of columns are used in the structure. According to slenderness ratio, columns are divided into two types. Short column. Long or slender column. The slenderness ratio, or simply slenderness, is the quotient between the height and the width of a building. Short column. A short column is the one whose ratio of effective length to its least lateral dimension is less than or equal to 12. Then it is termed as a short column. L FB equals 12, where L F equals effective length, B equals least lateral dimension of column. Important characteristics in short column. Short columns will fail only because of crushing or direct compression. For short column, Rankin's theory will be applicable. For short column, lateral dimensions will be quite large as compared with the length of the column. For short column, slenderness ratio will be less than 45. For short column, ratio of effective length of the column to the least lateral dimension of the column will be less than 12. For short column, load carrying capacity will be increased with decrease in length of the column. Long column. Long column is basically defined as the column in which the ratio of effective length of the column to the least lateral dimension of the column is more than 12. L F B 12 in long columns. The permissible values of stresses in concrete and steel used for short columns should be multiplied by a coefficient C R, given by the following formula. C R equals 1.25 L F for 8B, where C R equals reduction coefficient. L F equals effective length. B equals least lateral dimension of the column. Let us consider the following figure, which indicates a column, and we will figure out here the condition to accept this column as long column. Let us consider that length of the column is loss displayed in following figure. We have considered here the cross section of the column is circular or rectangular. Cross-section of the column might be any section such as T-section, hollow rectangular section, hollow circular section, I-section, etc. But we have considered here only two sections, i.e., circular cross-section and rectangular cross-section. Effective length of the column, i.e. length of the column which is bending, LE equals L. Diameter of column of circular cross-section equals D. Width of column of rectangular cross-section equals B. Depth of column of rectangular cross-section, laughing face. If we will first consider the case of column with circular cross-section, here we will have least lateral dimension as diameter of circular cross-section, i.e. D. So, we will have condition to accept this column as long column for considering column as long column, LED, greater than 12. So, we will have condition to accept this column as short column for considering the column as short column, LED, 12. Difference between short columns and long columns. No. Short columns. Long columns. 1. If the ratio of effective length to its least lateral dimension is less than or equal to 12, then it is called short column. If the ratio of the effective length of the column to its least lateral dimension is greater than 12, then it is called a long column. 2. The effective length to least radius of gyration ratio is less than or equal to 40. The effective length to least radius of gyration ratio is greater than 40. 3. Buckling tendency is very low. Long and cylinder columns buckle easily. 4. The crushing tendency is very high. It has a very low crushing tendency. 5. The load carrying capacity is high as compared to long columns of the same cross-sectional area. The load carrying capacity of a long column is less as compared to a short column of the same cross-sectional area. 6. The failure of the short columns is due to their crushing. All the long columns fail due to their buckling. No. Short columns. Long columns. 7. It has more radius of gyration. It has less radius of gyration. 8. It has a high load carrying capacity because of its low height. It has less load carrying capacity because of its more height. 9. They are subjected to compressive stresses. They are subjected to buckling stresses. 10. Its slenderness ratio is less than 45. Its slenderness ratio is more than 45. 11. Short columns have a large lateral dimension as compared to its height. Long columns have a small lateral dimension as compared to its height. 12. The short column is stronger than a long column and it is highly preferable. Long column is weaker than a short column and generally, it is not preferred. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.